All right. Hello and welcome everybody. I'm going to go ahead and record this. So whether you are here or not, you'll be able to get the information that we're working on. And I would like to um, have you guys start off with any questions that you have. Let's just make sure we get a chance to tackle that. So I've enabled screen share and you can bring that up. So whoever wants to go first.
I have a project that I'm working on. Maybe we can kind of review it and set it up so that when I can finish it on my own.
Perfect. Yeah, that'd be great.
Okay, I'm gonna just pull it up and give me 1 second.
All right.
Okay.
And while you're doing that, Miriam, if you had anything from the homework or if there's any like practice test questions or anything from lectures that you wanted me to clarify, you're welcome to find those as well. Or
Yes.
did you have a was it more of a project that you wanted to work on as well, or was it more questions?
No, no. It's some homework questions. Yeah.
Gotcha. Okay. So Cindy, whenever you're ready, you can bring that up, and then after that, we'll go ahead and get to the questions.
Okay,
Okay,
perfect. Thank
sounds
you.
good.
Hmm.
I just have it pulled up now, so share. Okay.
All right. Cool. So.
The project is data collection. Collect data for a simple real life scenario. This could be anything that involves two variables such as time and distance, sales and profit, and ice cream sales. Data entry in Excel, visualization, trend line, equation of the line, analysis. Here's the breakdown, the points that will be received, and I kind of just go by some examples of what my colleagues have done. So time, distance. I don't know what this one is about.
Yeah, so these examples can be really helpful because it does kind of give you the idea of the pattern of what that's supposed to look like.
Yeah,
Um, so maybe like we'll look at one or two others.
this
Okay,
seems to
cool.
be cheese in the US.
Okay, so cheese production, cool.
Mhm. And then people did, my project is ice cream sales. Huh. So I think my first step is to choose what I want to like collect data on.
Mhm. Gotcha. Well, you want to make sure that you're going to pick something that has a lot of data on it. So it could be, it could be price levels. That would be good. There's a lot of data on that. It could be.
Okay.
I mean, I'm just throwing things out there. It doesn't have to be any of these. It could be population size. It could be, but let's see what the um, uh, so it says selection of a relevant real life scenario involving two variables, and you want to see if those variables are correlated. So it says such as time and distance, sales and profit, temperature and ice cream. Okay, so people are like literally using these examples. That's kind of funny.
Yeah.
Um, yeah, so those are yes, those are safe, but it doesn't have to be. It doesn't have to be any of these examples. It can be your own that you find interesting. So I don't know. What are some things that you're interested in?
Maybe like the price of a gallon of milk and how
Okay.
that's changed over the years. I think that's a popular one.
Okay. So time and price of milk. Okay. That is cool. Yeah, you could do that. What's interesting about that is that milk is actually what some grocery stores use as what's called a loss leader. So in other words, they know that they're going to be losing money on their milk because they price it lower than um, what they would price it at if they were trying to make a profit. But it's a loss leader because people will go to the store to get the milk because they need milk more often than they need a lot of other goods. And then when they go there to get the milk, they've got everything positioned around the store in such a way that you're going to buy chips on your way to the milk aisle, or you're going to buy, you also need bread, you also need this, that, and the other thing. And so before you know it, you're spending $100 to get your gallon of milk, right? So you run in for one thing and end up leaving with a cart full. And
That's so true.
yes,
That's why they have it all the way in the back.
yeah, that's why they have it in the back. Exactly, exactly. Because if you could walk in and just immediately get your milk and walk out, you wouldn't buy all that extra stuff. You would just get your milk, right? And they but it's a psychological game to try to maximize the profit that the company can make. So they will use things like loss leaders like milk. So that would be interesting to see just how resistant it is to overall price changes, right? Because we know that overall prices have gone way up. I wonder how much milk has gone up compared to some other goods.
Okay, so it would be price versus time.
You could do it as price over time, or you could do it as price of milk as it relates to some other price. So you could have it as price of milk compared to price of gas, or price of milk compared to price of I don't know what's one of their more profitable things at the grocery store. I'm gonna guess. Um,
Meat?
what were you gonna say?
Meat?
Meat. Yeah, probably meat might be more profitable. So that would be interesting. Yeah, to see the price of milk versus the price of meat. Um, yeah,
I
anything
think I
really.
might do the one though that seems a little bit easier to me is like price over time. Do you think that would
Okay.
work?
Oh, absolutely. Yeah, it just has to be two variables. Price and time are commonly linked together, and you can see that she had distance over time, and this one was production level over time. So you could definitely do that. Um, yeah, and I think that when it comes to like price of, um, price of goods in the recent years and how much more expensive they've gotten, that's definitely something people are interested in. So that makes for a good project.
Okay, so I'll do the price of milk over time.
Mhm.
Um, and then I guess how do I do the trend line information? I guess I have to do something like this chart.
Yeah. So what you're going to do is you're going to, if you just start with a Google search, you're going to be able to get information. Oh, go ahead back to that. Um, go ahead back
Oh,
to what we had there. Yeah. So I'm going to talk about this part for a second here.
okay.
So, oh, somebody just came in. Um, All right, welcome to those of you who are just joining us. If you want to write your names in the chat, I'll send the proof of attendance. And I'm also going to send a recording of this to everybody so you can see where we started and anything that we discussed here, you'll all get access to it. So even those who weren't able to make it today. Okay, so with this part, the chart is going to go from 2013 to 2023, and those are basically the X values here. And then you have your Y values, which is the production level, and you can see that when you go to insert, which I don't know if this is like a screenshot of this or if this is actually in Excel, but if you're looking at um, the Excel or the Google Slides. Oh, we got somebody else here too. And if you're looking at the insert menu, you're going to be able to find insert chart, and then the chart that you're looking for is
Okay.
scatter plot. And so you're gonna select insert scatter plot while you have this highlighted. So this all needs to be like you would highlight this whole section here, and then look for scatter plot under insert, and then that's what's going to create this table right over here. And then in order to get the trend line, you have to go to, there's like a little plus sign here, and then it's buried pretty deep in there. You're gonna look for insert trend line, and then that's gonna make this. And then you have to go and click on that arrow too, and look for show regression equation, and that's this part right here.
Okay.
There are YouTube videos about how to do this,
Okay.
like specifically this part. So if you get stuck on trying to find the where the trend line stuff is in there, you could just look up trend line Excel um,
In YouTube.
scatter plot. Yeah, in YouTube, it'll come up. Yeah,
Okay.
YouTube's got really good search algorithms for that.
Okay, awesome. Thank you.
Hmm.
But would I need to find what the Y and the X is on my own or
No, 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 no. Yeah, the equation to do that is pretty involved, and I would not attempt to do that by hand. If you make one mistake, I mean, it could take you like an hour to do that equation,
Yeah.
and if you make one mistake, it'll be wrong. We use computers to do all these things for us now, so
Okay.
you just have to know how to use the technology to come to those calculations. There's no value in actually doing those calculations by hand. No one does that.
Okay. But you basically said, just to recap, I know I can look at it on YouTube, but highlight the
Hmm.
table of the data
Hmm.
and then go to insert, and that's how I find my scatter plot.
Right.
And then to find the trend line, do I
Hmm.
highlight the table again and then look for the trend line
No,
or
you're gonna click on this part right here, and there's gonna be like a little plus that
oh,
comes up, or
okay.
somewhere there's like chart settings or chart tools or something like that, where
Okay.
it's talking about like and that's how you're also gonna add these axes. So you're gonna be able to add a title. You're gonna be able to add these axes, right? And all of those options are in the table. So when you have this table clicked, I think there's a little plus icon right over here, and you click on that, or it could be three dots, something like that.
Okay. Okay, got it.
Um,
Thank you.
yeah, so they're always kind of updating it. I guess it depends on which version you have, but that's broadly speaking, that's how you do it. And again, if you go on YouTube and you want to do a scatter plot, uh, that's what you're looking for is scatter plot Excel, and it'll and trend line if you add in the word trend line.
Okay,
There's people who will show you how to do that.
awesome. Okay, thank you.
All right, you're welcome. And I think we have one more person that joined us. If you want to put your name in the chat, I'll make sure that you get a proof of attendance at the end of this session. And I get is that as much as you needed to know for now, Cindy?
Yes, I'm gonna stop sharing.
All right, cool. And so I'm gonna turn it over now to, I think Miriam had something ready to go. Is that right, Miriam?
Yes.
All
Yes,
right,
yes. Just like a few
perfect.
questions in the homework that I find it a little complicated. Um, Let me share. Hold on.
Oop, looks like we lost somebody. Hopefully they come back.
Okay. Do you see it?
Yes.
Okay. Yeah, I haven't started. I just want to review a few questions, like the first uh maybe we can do like the first 3 or 4 together.
All right, sounds good. So it says, which ordered pair could possibly be a solution of the graph system of equations, and why? So I want to, so for some reason it's not letting me write it on the screen, but we can talk about it. The
Mhm.
top the top right quadrant of uh, the coordinate system. So you have your coordinate system here where you've got your X and your Y. The origin is where they cross, right there in the middle. That's 0, 0. And all of those values on the top right are going to be positive, right? So in quadrant one, all the values are positive. In quadrant
Mhm.
two, which values are negative?
X,
The X values are negative, right? But the Y values are positive. Then quadrant three, what about the signs?
we have both X and Y being negative in quadrant three.
That's right. Quadrant three has both X and Y negative. And then quadrant four,
Y is negative, X positive.
perfect. So where is our solution going to be located? Where do the blue lines cross?
Quadrant three, if I'm not mistaken, looking at the
That,
graph.
that's right. That's right. So quadrant three is where our blue lines are crossing. So as we look at our potential answers here, which one of those is viable?
The negatives, could it be C?
D, negative, negative, right? That's in quadrant three. That's exactly it.
Well, that was pretty simple.
Mhm. All right, so determine whether the given ordered pair is a solution of the system. So what does it mean to be a solution of the system? Who can tell us what a solution would be?
So it would have to be like, so for the ordered pair to be a solution, the X and Y values should work for both equations.
That's correct, exactly. And it works for both equations at the place where it crosses, right?
Yes.
So we're going to put a 5 in for the X, we're going to put a -2 in for the Y. And after making those substitutions, if we have a true equation, in both of the equations, because you're right, it could work for one, but maybe it doesn't work for the other. And it has to work for both equations in order to be a solution of the system. So you guys go ahead and do that. Each of us can work on that, and then we'll compare notes on whether or not this actually is a solution to that system. And let me know when you guys feel confident about your answer. Maybe everybody put a 1 in the chat once you feel like you have your answer. That's how we'll do it. So I want to make sure to give you guys enough time.
Ooh. Sorry about that. Looks like the first one is a solution, but not the second.
Is that what everybody else got that too? Raise your hand if you agree, or yeah, type it in the chat. Yep.
Yeah, also had it not being a solution.
Cool. All right. All right. Go ahead and select that, and I think we're on track there. All right. Cool. And maybe let's do one or two more from Miriam's, and then if anybody else has questions, I want to give them a turn to be able to bring that up. So match the system with the correct graph below. Miriam, do you feel like you'd be able to do that now that we talked about the first couple, or
Yes,
do you want to do
yes,
that? Let's skip ahead then to some of the
yeah,
questions from towards the end, because sometimes they
yeah.
get a little more challenging as time goes
I
on.
agree. I agree.
Yeah. All right.
Hmm.
So this one asks us to solve the system of equations by substitution. So I would like to at least maybe do one by substitution and one by elimination if we can find an elimination problem too. They will actually both work for each. So it doesn't have to be it's not like only one works in one situation and another works in another. They both will work for every situation. It's just sometimes easier to use substitution in some cases, and it's easier to use elimination in other cases, but you still get the same answer either way. So I wanted to make that point so that you don't really stress too much about making sure you're using the right method, because it really won't matter unless it just gets really cumbersome. I'm going to go ahead and start a whiteboard because I'm not able to write on this. So hopefully you guys are all able to see this now. So the whiteboard is going to, oh, I took a little snip here and I'm going to type this out now. So this is, sorry, I'm just trying to get things arranged here. Okay, so this is 2x plus y equals 24 and y equals 4. And you guys should be able to see that now, I think. So what step are we going to do first?
Substitute it into an equation.
Oops, I made a little bit of mistake. Does anybody see the mistake I made? When I was typing this out, I forgot the x here. That was y equals 4x. Sorry about that. Okay, so you said we're going to substitute that, right?
I believe, yeah, I think so.
So what are we substituting where?
The first equation.
Okay, what are we going to do with it?
So you would put like 2x plus, I just feel like I don't want to say anything wrong.
It's okay. It's okay. This is the place to get it wrong, is in practice. So yeah, you want to make sure all your mistakes you make during the test or during the homework, so it's not during the test.
Yeah.
So yeah, what's the plan?
I mean, the way I think I would put it is like 2x plus 4x equals 24. Just
Love
makes
it.
sense. It's common sense.
Yes,
I feel like,
absolutely. Because we know that y is equal to 4x. So if we take that fact and we
yeah.
replace in here y, then what that allows us to do is have it so that it's all in terms of only one variable. And now that it's only in one variable, we can add those together because they're like terms, right? So that gives us 6x. 2x's
Mhm.
plus 4x's is going to give us 6x's. So now we've got 6x equals 24. And we're going to divide this by 6, divide this by 6, and these are going to cancel out. So this is going to be x equals 4. All right. So we're almost there. We still have one thing left to do. Now that we've discovered that x is 4, who can tell me what to do next?
You have to find y
You have to find y, and what's going to allow me to do that?
by plugging in x.
We know what x is, so we can plug this in, and you can actually plug it into either equation, but it's so nicely set up here. So I can substitute it right in there and get y equals 4, and then this is going to be times 4, right? So y equals 16. So when x is 4, y is 16.
Would I just plug it in here?
Yep, that's going to be your answer. So I'm going to go ahead and stop sharing this
Okay.
right here, and you can actually go ahead and share. You can bring your screen back up again.
Is my screen not? It's not being
Yeah,
shared?
when I took over the whiteboard, that stopped
Oh,
your
okay,
share.
okay, okay.
Yeah.
Give me 1 second. Oh,
So yeah, let's try that again. What would you do different this time?
um,
Are there infinitely many solutions? Will any solution work? Or will
no.
there be multiple solutions? So if there's two straight lines, wherever those lines cross, that's the solution. But there's only going to be one in the case of two straight lines. So it could either be if they're parallel, then there's no solution. If it's the same line on top of itself, that's infinitely many solutions. Uh, and if there's a crossing of those two lines, then there's only one spot where it equals each other, and that's going to be um, where there's a finite number of solutions. The solution set is, and we're just going to type in our values here.
Would I just put here like I would put like I just don't know how to type it. Like, is it do I put 16 or
You
So
have to
the
put parentheses.
you have to put it in parentheses, yeah, because it's a coordinate.
oh that okay. Yeah.
Yep.
That's what I
A-
thought because this is really picky with that stuff.
Absolutely, yeah. It has to be in this format. It must be in parentheses with a coordinate. And then, Cindy, I'm sorry to cut you off. What else? What else do we need to have true about this?
Um,
Does it matter what order we
okay.
put those numbers?
Yes, it does.
What order must they always be in?
X and Y.
X and Y. So we found out that X was 4 and Y was 16. So that's
Mhm.
exactly the order it has to be in. It must be X comma Y.
Yay.
All right, cool.
Let me see the last one. Let me see which question is kind of like oh, this is like another one.
Yeah, that's another substitution question. And that one had some fractions, which is okay. We can deal with the fractions. If you want to do that one, we can try that.
Okay, yeah. Yeah, let's do that. Fraction scare me.
Okay. So I'm going to take another snip of this and then work it out on the whiteboard. So just give me another moment here, and I'm going to share my whiteboard. Okay, so this was X equals 6Y plus 30. And X equals 3 over 2Y. And that little star that I put there, that means multiplication. That's just like the computer version of the little dot that you put for multiplication. So what I can do is I can replace where I see X in the top equation, I could replace it with 3/2 times Y, right? So this is going to go in here. So I'm going to have 3 over 2 Y equals 6X or 6Y plus 30. So if I wanted to get rid of fractions, is there a way I could do that? Is there a way I could get rid of that fraction?
Hmm. Would you multiply two by both equations? Or
Absolutely.
yeah,
Absolutely. I can multiply both equations by 2. And in fact, I could multiply it by 2 over 3
yeah.
because I noticed that these are all divisible by 3, right? The 6 is divisible by 3 and the 30 is divisible by 3. So if I multiply both sides by 2/3, I'm going to get my y by itself. And then these are going to be a little bit smaller. So this is going to be multiplied by 2, but divided by 3. So when I multiply 6 by 2, that gives me
Oh, 12 divided by 3 is 4.
That's right. So if that's a little hard to follow, you can always turn these into fractions also. Uh, and then you're multiplying numerator times numerator and denominator times denominator. So just like he said, it's going to be 6 times 2 is 12 divided by 3 is going to be 4. So 4y. And then 2 times 30 is 60. 60 divided by 3 is 20. Or you could cancel if you wanted to cancel first. You could do that, right? That would give you 10, and then 10 times 2 is 20, and you'd cancel this as well. And I gave you 2. 2 times 2 is 4. That's kind of the way that I do it. Is I instead of multiplying first, I divide first. I get the division out of the way, and then I do the multiplication. But either way, we end up with y equals 4y plus 20. Now, it kind of looks like we have it solved for y because y is by itself on one side of the equal sign, but notice that there's another y over here. So we don't actually have it solved for y yet because there's multiple y's in this equation. So we have to get all of our y's grouped over to one side. So what do we want to do? To move a whole term, what do I do?
So you'd want to move either 4y or y to like so they could be on the same side. It might be easier if you just move the 4y, have it negative 4y. So it'd be negative 4y plus y.
I like that plan, EJ. Good idea here because when we subtract 4y, we've got our y's exactly where we want them. So it's right over here. Now we have to deal with a negative, but that's okay because we can get that done in the next step. What are we gonna have to do to get y by itself here now?
Divide by negative.
We're gonna divide by -3, right? And that's y equals -20 over 3. All right, so we found out what y is equal to, right? Y is equal to -20 over 3. So x is 33 over 2. And then this is going to be minus 20 over 3 that we're replacing the y with. So the 3's can cancel out, and then 2 goes into 20. So this is going to be x equals -10. So that would be our solution here because we've got our x and we've got our y. All right.
Okay.
Anybody got questions about solving this one?
No?
I'm gonna go ahead and stop share then, and um, here we go. So you can bring that back up, Miriam.
Yeah.
And if anybody else has questions ready to go, let me know, and you can share next after we do this one.
Oh my God, this is so complicated.
You probably just need to press the left arrow. Okay. That's all right. Yeah, you're where you need to be. You could type it in now.
Let's see. What
Okay,
is
you got to
that?
make sure there's a parentheses at the
Yeah.
end of it. So you just press the right arrow all the way to the end. Yep.
Oh my God.
It's the um yeah, you don't want to press that.
I know. I'm just pressing it with my hands, and that's why it's like not. Oh my God.
Okay.
If you want, I can stop sharing and I'll just like answer that on my own. I don't want to
Yeah,
like keep you guys.
that's fine.
I don't want to keep
Who
you guys.
wants? No, no, that's okay. So who wants to go next for sharing their screen?
So I'm actually on my cell phone, but would it be like possible if I just flip the camera onto my laptop?
Yeah, that's fine. You could bring that up, and then I'll take a screenshot of it, and then I'll work that out on the whiteboard.
Yeah, sorry. Once I turn off the camera, it just went away. So
Yeah, no worries, no worries. Okay, so I'm gonna get this screenshot here. It's a little bit blurry still.
is that any better?
That sometimes, yeah, I got it. Okay. So I think it's x plus y equals -5 and 5x minus 3y equals 7. Is that right?
Yes.
Yeah, and we could just usually for something like that I'll just read it off as well. That usually works okay. So this is going to be x plus y equals -5 and 5x minus 3y equals 7. All right. Um, so we're going to probably want to, we could solve this any number of ways. One of them would be elimination. I would be happy to do one with elimination because we haven't really gone over that yet. So, uh, and this is nicely set up for it too. So you can cancel either the x's or the y's. It doesn't really matter which. I'm going to cancel the y's in this case. I'm going to multiply this by 3. And so this is going to multiply each of those by 3. And when I do that, that's going to allow the 3 y's to cancel out. So we're going to see what that looks like. So when I multiply by 3, what is that top equation? Anybody can just chime in, and
3x plus 3y equals -15.
so we just make sure we multiply each and every term. One of the mistakes people make with this is that they'll do the 3x and they'll do the 3y, and then they'll forget about the constant over on the other side. EJ didn't do that. He remembered that he had to multiply that 3 times the -5 to get that -15. Always got to do that. Okay, and then the bottom equation, that's going to be 5x minus 3y equals 7. I'm just rewriting it. Now, when I add these together, these will cancel out, right? these 3y minus 3y, those cancel out. And then the x's, 3x and 5x, that's going to be 8x equals, and then this is negative 15 and 7. So that's minus 8. When I divide these by 8, those cancel out. X equals negative 1. And now I have to go back and I have to substitute this into the place of x here, right? So negative 1 plus y equals negative 5. And then I'm going to have to add 1 to each side. So I get y equals negative 4. And that is going to be our solution. All right. Any questions on that one with the elimination? So you can, just to recap the process, step 1 is make sure that these cancel out. So you'll have to multiply if necessary to make them cancel. Make a variable. What happens if both variables cancel, by the way, when I do this? What does that mean if both the x's and the y's cancel? What does that mean?
There's no solution.
That's right. Yeah, it could mean there's no solution if we end up with something like 0 equals 8 or 0 equals negative 8, something like that. That would have ended up giving us no solution because there's no time ever that 0 equals negative 8. That's not a true statement. However, if we ended up with something like 0 equals 0, then that's always true, no matter what. So then it wouldn't matter what x and y are. That would just always be true, right? So what happens there, when that happens, that's because it would be something like x plus y equals 2, and then negative x minus y equals negative 2. An example of that, this is really the same equation. It's just this one is multiplied by negative 1. And so when we add those together, we end up with 0 equals 0. And that's because it's just the same equation. So it doesn't matter what x and y values we have. It's always going to be true for any x and any y. Right? So that's not the situation we have here, of course. These are two different lines that cross somewhere, right? So those two lines, they don't necessarily have to be perpendicular. They could be something like this, but they have to cross somewhere in order for there to be a solution. And in our case, there is a solution, right? And that solution is at, as we said, x equals negative 1, y equals negative 4. All right. Everybody okay? Oh, yeah, go ahead.
So is that the entire equation or question itself, it says solve by graphing. So we got the negative 4.
Graphing. Okay, I thought it was elimination. I'm sorry. Yeah.
Yes. So that's the first point. So my thing is, I'm not sure if it'll just be one linear line or two in which they cross. So I didn't get this question right the first couple times I tried it out.
Have you guys used Desmos?
Desmos, no.
All right, so I'm going to bring up my screen share here. And this is going to be, so actually I'm going to just stop the whiteboard and cancel this. Okay. And now I'm going to bring up.
Dad, is your suitcase in the car?
This. So you guys can see this, right? Everybody sees my Desmos?
I can, yes.
I'm going to put in x plus y equals negative 5. And I'm going to put in for the next equation, 5x minus 3y equals 7. Notice that I don't even have to do any
math,
algebra or anything like that. I just get the answer. It's right there. -1, -4. Now, if you try to do this by hand, it will be a mess. You have to be really careful with your everything you're doing and use rulers and everything like that. But if you're using a tool like Desmos or your graphing calculator, if you have a TI-84 or one of the Casio models, something like that, then you can get to that very easily using technology. But if you're doing it by hand, you could still get there. You can still graph and get your solutions, but you have to be really careful to make sure that your lines are perfect. All right. So again, the website for that was desmos.com. You don't need a graphing calculator to be able to do those by the graphing method. You can just plug those equations directly into Desmos, and when you go there to the website, it'll look like, let's leave. Okay, it'll look like this, and you just click on Open Graphing Calculator. So right there, Open Graphing Calculator takes you to this.
And one more time, can you just, so do you have to use the second line for the second equation, or you just put both equations in the first line?
When you hit enter, it'll automatically take you to another line for the next equation.
All right, perfect. Thank you.
All right. So I think that's as much time as we have for today. Thank you guys so much for coming to this session. And like I said, I'm going to email this recording to you as well as proof of attendance. All right.
Thank you.
You are welcome. Have a great day, everybody.
Thank you,
Thank
Professor
you.
Rogers. Have a good one.
All right. You too. Bye-bye.